and let's start talking about motion or kinematics. Okay, in AP Physics 1, we studied several different types of motion. We studied one-dimensional motion, constant position motion or at rest, constant velocity motion, so something moving along at a constant rate in one direction, or constant acceleration motion. Okay, all of these we studied in Physics 1 as a 1D motion. Then we progressed into 2D motion where it's moving both in the X and the Y direction. And then we talked about circular motion, things going in a circle, uniform circular motion, that's what UCM stands for. And then we began talking about simple harmonic motion. That's something that is oscillating back and forth, back and forth, back and forth, like on a spring. It's actually very, very common motion. And then the last one we talked about is rotational motion, where something is spinning about an axis. We're going to cover each one of these in turn in a different video. All right, so let's get started. Actually, we're gonna break up 1D motion into a couple of videos so they're not too long. So our first one is going to be, we're going to talk about dot diagrams. So 1D motion is moving up or down or left or right in one direction. So remember dot diagrams. Here we go. So a dot diagram would look something like this. So we have two objects, the red one and the blue one. And the red one is obviously moving faster. How much faster? Well, we can tell that at time equals 0 they were here, and at time equal 1 the red one had moved 20 meters in 1 second. So this one's moving twice as fast as the blue one, which is only moving 10 meters per second. How can we tell they're moving the same speed? Because they have the exact same distance in between the dots. So the red one's going to start here, moving to the right at 10 meters per second, but it's going to be accelerating backwards or to the left, negative. So it's going to be slowing down. The blue one is going to start at rest. It has no velocity, but it's going to accelerate forward. Okay? So have in your mind what the dot diagrams will look like, or the motion diagrams will look like. So here we go. You can see the red dots are getting closer and closer together, and the blue dots are getting farther and farther apart. Tell from these diagrams that the blue one is accelerating to the right because the distance is getting farther and farther and farther each second apart to the right. You can see on the red one that it slowed down when it was going to the right because the velocity was to the right, but it's, let's reset it and show it again. Its velocity is to the right, but the acceleration is to the left. So the dots are getting closer together. But once it turns around, the dots start getting farther and farther and farther apart. Since the velocity and acceleration are in the same direction, it's speeding up. So let's look at a couple examples. So if we look over here, we've got a problem. Students track the motion of a car moving horizontally from left to right by placing a dot at the position of the front of the car every 2 seconds. They produce the preceding motion diagram that's up here. Which of the following velocity time diagrams is consistent with this motion diagram? Okay, so a couple of things. Number one is we're talking about a velocity versus time graph, not a position time graph. So let's look at what the velocity is doing. So you can see right here in this section we have a small or low constant velocity. So a small constant velocity. In here we have a much larger constant velocity. Okay, and then here you can see the dots are getting farther and farther apart. So here we have an acceleration to the right. Okay, so what would that look like on a motion diagram? Well, which one of these, in a velocity time graph, which one of these shows a acceleration, a large velocity, then a small velocity, but that's constant here and smaller here? Okay, so this shows an increasing velocity the whole time, so that one's right out. This one shows a negative velocity down here, so that one's out. This one shows a constant low velocity and constant high velocity, constant low, constant high. So the only difference is this section right here. This one shows a constant velocity at the beginning, whereas this one here shows an increasing velocity. So this one shows a positive acceleration here. So A must be our correct answer. All right, so let's look at our second problem over here. So in this particular problem, it says, so we've got a car, is stopped at traffic, the light turns green at time equals 0, the car starts moving and traveling with a constant acceleration. At the same instant, a truck is traveling at a constant velocity, vt, and is alongside the car with the front of the vehicle at a position x equals 0 as shown above. So they're both exactly at the same spot at the same time, and the truck passes the car, but the car later catches up to the truck in front of the house over here at point D. Okay, so what's that going to look like? Well, the truck is going to have a dot diagram that has dots that are the same spacing, whereas the car is going to have dots that start at the same place, but they're going to be small, and then they're going to have to get bigger. So 1, 2, 3, 4. If that's 4 seconds, ooh, I don't have them nearly far enough apart, do I? So here's 1, 2, 3, 4. Okay, so this is time equals 0, 1, 2, 3, 4 seconds. And this is just an approximation of what the answer would look like. Okay, so the truck has the same spacing, same speed. The car is going slower, you can tell, and then it's going faster at the end. But it's caught up, they're in the same place at the same time. I have a simulation of that, so let's take a look at that. And there we go. All right, there we go. So the car catches up with the truck, very similar to what I drew down here. All right? And there we go. There's our dot diagrams.